You've connected to Cisco Unplugged.
Hello, everyone, and welcome to Cisco Unplugged. My name is Dan Klamert. I'm your host. And this week on episode 56, we're going to be discussing AI-driven RRM or AI-RRM and its benefits. So I would like to take a second here or a moment to welcome back Al Dumdei to the show. How are you doing, Al?
Hey, good, Dan. I'm again looking forward to this. This is I like to refer to Vishal as kind of the godfather of AI-RRM. So
Yes, yes.
anytime you get to talk to the godfather here, right?
Yeah, so speaking of Vishal, so I'd like to welcome a very special guest here to the show here. We've got Vishal Desai, and as Al had mentioned, he is actually, other than being the godfather of AIRM, he is a 19-year Cisco vet, and he's been working as a principal radio resource architect in the networking experience group. He works in AI-driven wireless services team that spans from PHY optimizations to enhancing wireless services with artificial intelligence. And Vishal has won multiple Pioneer Awards inside of Cisco for building innovations in the wireless portfolio and domains. He holds over 178 patents in U.S. patents in the area of distributed systems, wireless communications, and resource management algorithms. That's really impressive. And he also has a BS and a MENG in computer science from Cornell University. And in his free time, he likes to volunteer for Cub Scouts, do gardening, and also biking with his 7-year-old. So welcome to the show, Vishal. Vishal, how are you doing? And you saw our picture there. A picture from live last year's Cisco Live, where I had the pleasure of meeting you. So hopefully you're okay with us sharing that. You're a fun guy all around too. I can vouch for that.
Thank you, Dan. Thank you, Al. Thank you for having me. It's my
Thanks.
pleasure.
Thanks for joining us. Appreciate you being here. So, just a couple reminders real quick before we get into the show here. As usual, this is being recorded. It's available on our YouTube channel, youtube.com/@getunplugged. So please be sure to like and subscribe, turn on notifications so you are notified when we do go live with great episodes of great content like this. So now let's get unplugged. So Vishal, could you tell us a little bit about your and Cisco's journey to AIRM?
Um, the journey of AI-RRM in Cisco has been quite fascinating. Almost 9 years ago, we had this concept of bringing artificial intelligence into some of the RF management functions
Sure.
that we do on the controller. We socialized that idea with few folks. It did not go anywhere. Thankfully, we connected with our CTO and a chief network architect, Pradeep Kathil, and he actually helped us submit an application to this centralized tech fund that was led by David Walt many, many years ago.
Okay.
That really helped accelerate some development in this. So we got the budget from the tech fund. We hired a couple of contractors. I built the first prototype of sort of pseudo AI-RRM version that was 7, 8 years back, running in AWS. And the goal was to sort of show how it can provide substantial benefit over the traditional system that we have been running on millions of access points. From the project point of view, I felt we always worked as a mini startup within Cisco, where we have to prove ourselves over the score of many years, many, many times to show that how this is significantly better, what are the benchmarks that we have collected, and that helped integrate this into a product. As the AI wave caught in 6 years back, the BU finally saw that it aligns with the product roadmap. And we delivered this on the CAT Center 3 years back. And around the same time, we started our journey on the Meraki. And but just before the summer, we are planning to launch the service on the Meraki access point as well. So it's been a pretty very fascinating journey that's very close to my heart.
That is interesting. I didn't realize that this started 9 years ago.
So the concept started 9 years ago, and then
Yeah.
we had to go through, kind of few flaws and But it was a slow and steady journey that finally kind of made it to the product. So I'm very happy. Yeah.
What do you see as kind of the primary difference? I mean, this is obviously it's evolved over a number of years now, but what do you see as the primary difference? How is AI-RRM fundamentally different than just traditional RRM? Cisco's been doing RRM for many years, a lot longer than 9 years, right? So, yeah.
So if I were to give maybe the easiest analogy, I would say that if you compare the traditional RF or wireless management to um, um, running a flight, right? You're flying an airplane. This is with WLC RRM. It is more of you are an highly skillful pilot who is looking at the dials, monitor altitude meters, and then trying to do the course correct of your flight from one destination to another destination. With AI-RRM, it is more of like you are monitoring a highly intelligent autopilot service that is taking lion's share of the workload and doing a lot of heavy lifting. So you can focus on strategy and not just the operations. The three I would say the key differences between the traditional system and the AI-RRM is around how we approach the decision making. Traditional system is designed more of based on the rules, certain cost functions we have that looks at the telemetry from 5 max stats from the radios, and then does the optimizations as a reactive manner. AI-RRM on the other side is much more dynamic in nature. We have different sampling windows that we look at to identify short-term and long-term trends that we see in the wireless, because wireless environments are widely dynamic. And using those trends, we feed into the different set of algorithms and services where we use classic ML and deep learning techniques to generate more of a predictive insights and optimization. The second aspect is around how we treat clients. The traditional service is more around scheduled based. So we kind of configure a timer and schedule. So it kind of runs optimization at a fixed interval. AI-RRM not only knows the different traffic insights from the clients, but it also has this way of identifying what is the most crucial hours of operation that you have. And it has a way of distinguishing itself of using certain data during the crucial hours and running optimizations to avoid any client disconnect. And finally, I think the third point would be around the intervention of experts in the system. So as the RRM is a core service running on more than 35 million access points today, in Cisco Wireless being the largest vendor in the world, we always run into various specific deployments where there is some expert tuning is required in order to provide seamless client experience and increase the capacity of the radios. So that is one thing that AI-RRM tries to tackle, that based on the unique RF signature that we observe from the deployment, rather than asking an expert coming and tuning the network, we provide a customized, tailor-made recommendation for your sites based on the client association trend, roaming trends, AP interference profile. And then we provide that directly to the admin so they know that what tuning they need to do. Right. All of this comes with a single pane of glass, which UI that provides you insights around this RF trends, optimizations, anomalies, and the recommendation across both Catalyst and Meraki portfolio.
Okay.
Hey, Vishal, I think you touched on it a little bit there. Sorry, Al. And
go ahead.
when you mentioned about traditional RRM and some of the challenges there, and you specifically mentioned, I think one of those challenges when you're making those channel changes and whatnot, maybe power change, changes, whatever, is client disconnects, things along those lines. How is AI-RRM helping there? I think you talked a little bit about it, but what kind of real world results are you seeing there with AI-RRM, the differences?
Absolutely. So let's just maybe do it better, right? I have a use case where we can go over quickly to see how different set of customers we're seeing issues and how AI-RRM help. So if you don't mind, maybe bringing the slide here, please.
Okay.
Yeah.
This is, can everyone see the slide?
Okay. Looks good.
So this is a customer in Europe. It's a financial services customer. They have relatively decent size deployment of 650 APs, around 5,000 to 7,000 clients. And they were seeing a problem of clients getting frequently disconnected, right, in majority of their sites. And majority of the larger sites were completing this problem a lot more than the smaller ones. They also saw some areas of their buildings where they were seeing very slow Wi-Fi performance. The MCS rates of the clients were never achieving what they could do with the good class of access point that we sold them. So when we look at that, what were the concerns that they saw? The problem was that if you look at this graph on the bottom, you see a green line and an orange line. Green line represents the client count that they see, close to 400 clients. And then the orange line you see, if you superimpose it, it's essentially telling you the radio config updates that we make during that time. As the environment is dynamic for most of the wireless deployment, we see as the client comes in on the network, you start seeing high amount of interference and load and capacity issues. And that was driving the legacy system to kind of drive more and more configurations, and that was causing the disconnect. So one solution we can always think of is just shut down everything, right? Why we do any config changes at all, right? And here in this case, we saw that the config changes were increasing by 13%. So to answer that is, there's always a classic dilemma for Cisco and pretty much all wireless LAN vendors around when is the right balance to make between connection stability and performance. If you want to make your network adapt to the wireless interference, the new set of clients coming in, you want to maximize your capacity, maximize your throughput, you provide best-in-class wireless and do interference mitigation, noise mitigation, radar mitigation, etc. For that, you want to optimize your system as frequently as possible. The downside of that is you will have client disconnects. If you take other side and focus on connection stability and reduce the config updates, clients are going to be happy from connection point of view, but that performance will start getting pathetic over a period of time. So how do you maintain that trade-off between these two opposite end of the spectrum that you are trying to manage your configuration with? So if we look at how do we achieve today for the on-premise 9800 UI and the cloud-managed Meraki dashboard, we have a way to adjust this, but it's a very crude way. This example I am sharing here, we have this interval and anchor time that is configured as 8 hours and 4 a.m. as an anchor time. So what we are trying to achieve here is, look, we want to optimize your wireless network, but we do not want your clients to be disconnected because that is very important to you. So what we do here is with this configuration, you can, as a customer, this was the case with the customer in Europe, they configure it to 4 a.m. where most of the people are at home, right, unless you jet lag. And then at 12 noon where you are eating lunch. So hopefully, as long as the Wi-Fi doesn't disrupt your YouTube videos, you should be fine. And then 8 p.m. is where you are mostly gone home and with your family. So we can do those config changes without too much worrying about client disconnect. The problem there is we are looking at the measurements 10 minutes before the run. So which means that at 3:50 a.m., we are looking at a network which is more or less in a beautiful state, then trying to optimize it for the whole day, right? Which kind of makes a concern. On the Meraki side, we don't offer this customization. We run this service every 15 minutes, and that's the only way we can kind of run those functions for auto RF, right? So we had an option of trying to figure out what we do with these timers, but we took a little different approach. We said that if we get rid of these timers, because now we have access to the past trends, can we look at and approach this in a different way? Figure out that for every single customer side, there would be a set of times of the day where they are very crucial for them. If you are a retail customer, opening in the afternoon to late night is the one for you. If you are school, early morning to early afternoon is where your crucial times are. Sure. And we wanted to identify what those times are. So then we can do two things. Number one, try to minimize the configuration during those times. And second, which is more important, look at the data and bias our decision based on the data that we have during those times to optimize it at a later, right? Because ultimately what matters for you is your client density when it's at the peak or when your network is very busy. Those are the benchmarks you should be feeding in the algorithm, not the 3:50 a.m. benchmarks. So we came up with this concept of this busy hours, and then customers immediately asked that I cannot manually figure out, I have sites in many countries and many locations. So it kind of prompted us to kind of look at one of our innovations of AI generated busy hours. So this is the data from that same financial services customer. This was back in 2023. This is a Catalyst customer. And what we saw was, if you look at the 1st May here, nicely aligns with Monday to Friday, Saturday, Sunday, and Monday to Friday. And you can see that during the Monday to Friday times, the client counts was higher. Saturday, Sunday was lower. Friday was also, people were mostly working from home.
Mm-hmm.
And one challenge we saw was while it worked on certain deployment, some of the other deployment led us to busy hour of 24 hours, 7 days a week. And the reason was that any AI model, in my opinion, is as good as not only the accuracy of the data, but also the diversity of the data. And this was the first fumble we saw when we were trying to identify, where we said that there were certain clients that were always connected. This was printers, laptops, like those scanners, those devices that are always in the building. And if we try to measure the busy hour based on the client association simply, you will get those clients are always there for your network. So we had to kind of come up with this classification of stationary client versus mobile client. Then we prune those clients into the mix to only focus on the mobile devices that we have in the network. And then Friday, as I said, was an outlier. People were working from home, enjoying doing work-life balance. And then we focus, that's for the samples, we focus more on the content of the Monday to Thursday. That is where we saw a pretty good data. Friday was giving us more than 2 or 3 times the standard deviation anomaly, right?
Mm-hmm.
And long story short, we kind of feed this data into the model. At the high level, what we are essentially doing is we are feeding this client in. First of all, we denoise the data, focusing on 2 sets of parameter. Client stats, which tells you what kind of clients are there, when are they coming to the network, how long they are staying, and then TX RX util, which essentially represents your downlink and upstream utilization. That says how much traffic they are passing. And the reason why it is needed is we see these corner cases where access points at the corner of the site gets clients that come and go very frequently, because those are the clients not associated, they are just flying by.
Mm-hmm.
So we had to do certain skew towards the clients that are actually connected for a longer duration, passing traffic. And that would give us some good outcomes of what is the mobile patterns of the day during the clients are coming, associating, and that is where you want to figure out your crucial busier hour, right? We feed into the KNN classifier, came up with a prediction. We had to do certain small optimizations, because one of the things that we do for CAT Center customer is, because the privacy is at most important to them, we do not use any PII information. So we kind of normalize those hours. We do not know whether they are in which location. We convert everything to UTC time. We come up with a busy hour that was appropriate for that customers. And once we identify the busy hour, then what we do is we feed it into how we optimize based on the AI-RRM. So the same graph that I shared in the past, where the config updates were exactly aligning to the peaks of the network. Here we can see the config updates are essentially scheduled at the off phase from the client association to the network. That helps us 3 things. Number 1, during the busy hour, this is the green patch of thing. Hopefully you can see it right, where you see the config updates are reduced significantly up to 85%. So that is a great thing. Second thing is we can see that we are running all this offline calibration. And this is where we use the daytime's busy hour data and running those offline calibration. And then finally, we can see that as we are looking at a trend-based data, not a snapshot data, compared to the above graph, you will see that there is a wireless convergence achieved where every day we start making less and less changes, right?
Wow.
So this provides a very good stability for the wireless clients. And at the same time, we are continues to optimize the network to provide best capacity.
Very fascinating. So, so This is a great explanation in terms of like the busy hour and that sort of stuff. You mentioned three things, so I want to kind of back up just a little bit. And so we've kind of I wanted to drill down in each of those three, just a little bit of what you just said, right? So number one is the busy hour. And that was the question kind of that you just answered. How does that work? The other was we no longer have, and you pointed this out, with RRM, it ran every 10 minutes. So you could set it to an hour, twice a day, whatever you want to set. It was a periodic, it runs. And let's just take DCA, for example, right? You mentioned cost functions. We had the cost function, the cumulative cost function, where we determined, is it good for the AP to change the channel? Is it good for the AP's neighbors to change the channel? So all of this algorithm kind of ran in the background. And then there were timers with that associated with things like NDP timeouts and all that sort of stuff. We had to get all that kind of configured right for, to get RRM to work correctly.
Mm-hmm.
With AI-RRM, do we care about things like neighbor timeout values? Are we still running? Do I care about sensitivity values, like and cost functions, and because remember, there's, along with the cost and the cumulative, does cost and cumulative cost still exist in your calculations? I'm saying, how does that piece under the hood, how much of that is still used? Because I see profiles that have a lot of those same values that we used in the past, right? So is a lot of those algorithms still there?
So great question, Al. So let me try to give you a short answer and then little long answer. So cost function, yes, absolutely. The way in which you can think of AI-RRM is, it's not that we are saying that AI is going to completely throw away all the work that we have done, and you can just run AI into the mix and it's just going to produce magical outcomes, right? The approach that we in Cisco Wireless have taken is, we have proven leadership on running the traditional system on millions of access points, right? Yes, it had its shortcoming, but it's not that the traditional algorithms kind of did not work on most of the time. It actually worked very well in a lot of deployments that we have. The way in which we took an approach of AI-RRM is the cost function that we had, for example, in the DCA, was running based on the snapshot of data that we got from the radios, right? And that was driving a lot of instabilities, where we tried to create different dampening using inertia and other thresholds. Sensitivity is another example, to try to minimize the config updates so that successive RRM runs, DCA runs do not generate a lot of frequency updates, right? Those things are still very relevant. What is changed is how is the data fed into the algorithm. So rather than looking at a snapshot that can vary over a sample to sample window, we kind of look at larger windows to optimize the set of input that goes in. You asked me a question also about the NDP timer. So maybe I can use that as an example. The NDP timer, is it relevant with AI-RRM? The answer is no. The longer answer is that the NDP timer, the reason why we even had that was we were seeing instability in the neighbor measurements across the board. And it was our way to bring in some consistency by making sure that we can keep those neighbor measurements for longer duration. Now, why were we seeing the inconsistency? It could be because of your channel state, it could be because of your interference, or it could be also because of the regulatory. In 5 gigahertz, for example, if you're planning to transmit neighbor discovery, you need to look for your enabling beacon before you can transmit the neighbor discovery frame out over the air, right? And it's mandated by the compliance for these radios that is going off channel and transmitting NDP. What we saw is, because of that requirement of enabling beacon at DFS frequencies, we always saw that NDP was very, very flaky. So we see some APs have 5 neighbors, suddenly increases to 12, then goes back to 3. And those kind of inconsistency was leading to lot of unnecessary frequency updates, cell size adjustment, FRA impacts, things like that. So in AI-RRM, what we do instead is, rather than looking at the snapshots, we are looking at the trend. And in NDP case, what we do is, let's say you have a set of neighbors that are able to hear each other. Instead of taking a regular snapshot of those samples, let's say I hear from a neighbor on cycle 1, 2, 3, and then did not hear it on 4 and 5, and then again hear it in 6 and 7. Instead of removing those entries, we can basically have a way where we are stitching the data. So before we feed neighbor information to the algorithms, we said that in previous measurements, the neighbor was there, subsequent measurement, neighbor is there. It's only missing on 1 or 2 cycle. We kind of artificially stitch that neighbor as if it never went away and then feed it into the algorithm. That's giving us much lesser amount of the frequency updates, and it's also giving us much more stable outcomes.
Gotcha. Okay, interesting. So a lot of the same stuff happens under the hood, but we're just now able to kind of take that and use that over time, as opposed to everything based on these 10-minute windows or however you want to, whatever you had that set to in the past.
Exactly.
So what about, so let's say I'm doing a fairly dense environment. Maybe I want to have different profiles for different areas, that sort of, do I still have the ability to set different types of profiles for different parts of my environment and that sort of stuff? Does that exist with AI-RRM?
Absolutely. So we believe that every wireless environment is different and it is diverse. So having an ability to configure RF profiles, different RF profiles within a single domain of the radio resource management compute is essential. And therefore, we always supported having multiple RF profiles on even the legacy WLC based RRM as well, right, from the get-go. What we do, we take one notch up with AI-RRM. What we see is majority of the sites we see is now looking at thousands of APs instead of single, like hundreds of APs these days, right? Because people are buying higher capacity boxes that can support more number of APs. If you look at our Catalyst 9800 controller, we see they support 6,000 access points, right? And that means that a single controller could have multiple buildings, like 50 or 60 buildings, each of them have 100 APs each.
Sure.
Is it fair to assume that even the services they want to run from resource management are same? The answer is mostly no. So what we do with AI-RRM is not only we give RF profiles so you can tune your threshold, but we also give ability to run independent RRM algorithms at a different frequency, different duration, different sensitivity for each of those buildings, because each of those buildings could have a different RF signature based on whether it's a cafeteria, whether it's an auditorium, whether it's the classrooms and things like that.
So
Gotcha.
Vishal, I've turned on AI-RRM now. How do I know that it's working? Or what can I see what's going on?
That's a great question. I think that's the first question everyone kind of have asked. And
Sure.
thankfully, we got grilled so many times. So we have very decent answer here. So there are various ways you can understand the value prop of AI-RRM, right? The first is the most simple way, where what is the goal of any system that we develop in the wireless network? Two things. Number one, to make sure it provides a maximum capacity to the access points that we have. And then it provides the best-in-class experience for our wireless clients. That is what exactly AI-RRM tries to achieve. So if you want to look at those two pieces of key information, the single pane of view that we have called AI-RRM Control Center on the Catalyst Center, or for the Meraki side, we have the RF settings page that has the hero bar and a lot of those details. Sure. Gives you exactly that. It tells you the buckets of SNR representing how are the clients doing, what is the uplink, downlink SNR information, how is the interference going to look like, are we minimizing that interference over a period of time, and it gives you a very nice visualization to give you those insights. We also come across other set of customers who are not very wireless savvy. They are like, yeah, we do not understand all these MAC protocols, and
Sure.
give us some sort of a magical number that tells me, am I doing okay or not?
Sure.
For that, what we did is we said, rather than us figuring out a health score that we can improve or decrease, we said, let's look at how is field using today. So if you look at our sales partners, as you know, they heavily rely on something called wireless config analyzer. And that is where they manually parse the configuration, and then it produces the RF health index, which tells us how is the state of the wireless happening. So when we did AI-RRM, we believe that not just AI-RRM, but any AI system that we develop has to have a validation where it can identify a set of KPI where it's measured against. In other words, whenever we are doing any improvements with any AI service, it has to have a good set of KPIs that we use not only to track its improvement for model to model, but also a way of giving benchmarks to say that if this is improving or decreasing, can we also do a closed loop with that? So that's exactly what we did with the AI-RRM, where we look at the library of the health score, integrated that into the AI-RRM library itself. So that means that you are not only seeing the health score improvements that we get to see for those customers who don't know about the max stats and 5 stats, but also we use that as a feedback mechanism, the algorithm, where we say that if portion of your site goes down, your score has dropped significantly, we do a trigger to the algorithms and it runs those functions on demand to bring the capacity back up for the network.
Nice. Gotcha. So, and that kind of leads into that third, because again, your kind of 3 bullets you started with, the algorithm is not limited to that window anymore, the busy hour, that we can make changes during the off-peak busy hours. And then the AI insights, the feedback that you get. There's some of the feedback you get in terms of how your performance is. Is there anything else that from an insight standpoint that would be important to know about?
So I think the main thing I would say there is every network is unique, and what we feel is, at least what we have seen is, there is no magical threshold that will work for all the deployments, right? So that is where I think we try to figure out what is the right course correct we need to do for each of the network. And this is exactly what AI, part of AI-RRM, tries to tackle, where we continuously monitors a unique RF signature of each of the deployments. And beyond the customization and the already operational parameter updates that we do, we also provide a config guidance where we say that for your site, based on the client trends that we are seeing, we are going to analyze your system. So system looks at your data for 1 or 2 weeks. Based on the trends that we see, we generate config recommendations for your network as well. So that way, if you are an expert, you can validate what we are generating, whether it matches with you. And in a lot of time, it has happened that network admin disagreed, and then we proved, and then we could see the capacity went better. So we kind of had to do a hot walk, but ultimately kind of, helped us establish trust. And for the folks who have a single network admin for wired and wireless, which we see a lot more common than what it was before, it also gives them a customized guidance to recommend a set of tuning that they can do without really a need to understand the complexities of the wireless communication and the physical layers.
Okay, so it's almost like a closed loop now. So we have the kind of updated algorithms that operate, but they operate within a given set of parameters.
That's right.
Then you have the off-peak busy hour changes, but then you have the suggestion to the parameters to say, hey, maybe you're not actually operating in the right parameters. We suggest these changes to the parameters, and back up to the top of the loop you go again. And that cycle can kind of continue then throughout and it converges over time, obviously, as you showed, but kind of runs. So does the same kind of, does Meraki operate the same way then? How is it the same? Is it different? I mean, fundamentally, how do I look at the 2 algorithms? Are they the same?
So I think Cisco Wireless has started this initiative of single hardware that you would have seen. It is becoming now more prominent with Wi-Fi 7 launch, right? Similarly, we believe in having a unification of all software services and AI services, independent, irrespective of what customers you are. Are you an on-prem customer or a cloud managed customer? So if you can bring next slide, I have there. Where basically this is providing you a bird's eye view of how is the AI-RRM interacting with both stack, Catalyst and Meraki stack. The the simple answer is that it's the same set of algorithms, same set of services that supports both stack. Having said that, there could be different requirements and different optimization that we might have to do for different stack. One example I can give you is the profile of the customer we see on the CAT center side is slightly different than when we started looking at this for Meraki. CAT center, we have one single box that have relatively very large amount of access points that they all kind of subscribe for the service, and then we do an optimization for those massive amount of access points. Meraki side, we see similar high amount of access points, but they are distributed over a small context called network. And the service, we had to provide additional set of optimization so that we can aggregate data coming from those group of APs from a small network. And then they all align to a larger customer we call org in the Meraki side, right? So there were certain optimization that we did for how the data is ingested, data is optimized, data is normalized. But purely from the algorithm and the services point of view, it's a unified service that is supported for both stacks.
Okay. So the cost functions, cumulative cost functions, all that sort of stuff that normally runs under the hood, still there.
Yes,
So
exactly.
all that goodness that we've had for many, many years is still there. So
Absolutely.
interesting. So
That's great. Yeah, I just had one more thing here.
Yeah.
So we've had AI-RRM now for some time.
yeah,
And I'm assuming it's evolving, becoming self-aware, and going to take over pretty soon. But all kidding aside, but what's next for AI in wireless, Vishal?
So our immediate focus is we delivered AI-RRM 3 years back on the CAT center. This summer, we will be supporting AI-RRM on Meraki. We already have close to 500,000 plus access points across both Catalyst and Meraki portfolio so far. And we plan on seeing that number go significantly higher post the GA. Beyond that, we have quite a few exciting innovations coming in later this year. Some of them will be also launching in Cisco Live. Our approach of Cisco Wireless of integrating AI, I know there's a big wave, everyone is talking about AI.
Yeah.
Oh, no.
Is little different than what we see from some of our competitors. What focus on saying we throw AI into every single system we have and then try to make it very fancy. We look at what are the crucial issues that customers are fumbling today, right? One of the issues we see is how customers are troubleshooting the client connectivity in the network, right? It almost comes to a point where unless you are proven, you are always guilty. So you have to show there is an issue with the client, not an infrastructure, things like that. Can we simplify that process using machine learning or deep learning techniques where we can gather some information from the client and then gives you a very nice visualization that tells you exactly where the problem is, right? Other approach could be that we talked about RRM, but if you look at 9800 configuration, there are tons of configs that we have to tune also beyond the RRM. Can we provide some sort of overall framework that AI system can not only look at your radio operational parameter, but it looks at your wireless LAN, it looks at your security profile, and it evaluates your system as a whole and say that, can you optimize your controllers or dashboard so you can uplift the experience of your whole wireless network management system itself, right? How quickly you can bring in the new access points to the service. So as we see a lot of strong interest happening on the Wi-Fi 7, we see a lot of customers upgrading to Wi-Fi 7. And one of the things we are trying to figure out with artificial intelligence is, can we make the onboarding experience very easy for customers? So you have older set of access points when you're trying with upgrading the new one, rather than reconfiguring those VLANs and their configuration, can we just learn from what it was? And then when you even install, not only replacing those APs, but even install new set of access points, can we figure out that they belong to the similar ecosystem and therefore automatically provision them with some configurations? So these are the set of kind of things that we have, and we have few more. If you are a customer partner coming for Cisco Live, please visit us. I'll be giving a talk there as well, and then we have exciting demos lined up in the Whisper Suite and the World of Solutions. So
Yeah, will you have the hat and the glasses on, or how should we find you there live?
you
I'm
should
just
find
kidding.
me. Yeah. So
His Godfather hat.
Exactly. Love it. So
Yeah.
we're almost out of time here, but this has been awesome. Vishal, anything else you want to touch on?
No, I guess thank you for having me, and I am pretty excited of what tangible benefits AI is going to provide to the wireless network, and I'm pretty excited about what we have in the pipeline.
Yeah.
So please stay tuned, and we'll have more. So
Yeah, so
thank
are
you.
we. Thank you, Vishal. This is
Yeah.
great episode on AI-RRM, and hope to see you out at Cisco Live this year as well. But thanks so much. Thank you, Al. This has been great. Thanks to everyone for tuning in and watching. If just a couple reminders, if you need to reach out or want to reach out to us, you can get a hold of us via your Cisco account team. They know how to get a hold of us, or you can always email us at getunplugged@cisco.com, or you can send us DMs on X, Twitter at Unplugged 80211, or on Threads Unplugged Connectivity. So don't hesitate to reach out if you have any questions, or what you'd like to see as far as feedback for upcoming episodes, or to reach out with anything else. So thanks again, Vishal. Thank you, Al. Thanks for everyone tuning in.
Yeah.
And until next time, stay connected and unplugged.